Last week was a pretty big week for progress towards the mill. I finished the truck restoration and enhancements. Our first load of tools, equipment, and some of our boxes of possessions went up to storage on the island. It all went a bit wrong on the drive, but more about that in the next video. Most importantly of all, we received our listed building consent and planning permission for our first phase of works on the mill. Planning approval came through about an hour before the truck left, which made it a very exciting day. We still need the building warrant before we can start work on the roof, but we can start work on some parts of the mill as soon as we move up. In this video, I'm wrapping up the work on the truck. I'm running electrics, adding lighting to the box, improving some cheap LED spotlights, and installing a reversing camera. So settle in, because as an electronics engineer, this is my favorite part of the build, and it looks like it's going to be our longest video yet. The ferry to our island is reverse on, drive off. The truck has really big side mirrors which have good visibility, but it could still be challenging to make out the person guiding you on, especially when the ferries are low tide. In winter, the sun sets a little after 3 PM and only peaks above the horizon after 9 AM, so I also wanted some extra lighting than just the reverse lights. Initially, I bought some lights advertised as two 5-inch 36-watt work light bars. I thought these would provide sufficient light, but the product name was highly misleading. I got two 18-watt lights, which are 5 inches wide, making for a total of 36 watts, rather than 36 watts each. They also had a really weird beam pattern, which was like a narrow bar of light, so I sent them back immediately. I really didn't want to buy from a misleading brand again, but on Amazon and eBay UK, they pretty much dominate the low-cost LED light bar market, at least for lights which can handle 24-volt truck power. Next, I bought a single 12-inch 72-watt spot flood combo light. Running it on my lab power supply, it absolutely could not reach 72 watts. It would start at about 52 watts and rapidly settle down to about 48 watts. It had a beam pattern and brightness that I was happy with though, so I bought a second one to have one for each side of the truck. These are advertised as waterproof, but from a design standpoint, you can see the engineer has heard of waterproofing, but never really put much thought into it. One of the lights had a good 20mm gap on the front seal, which would have allowed water in. The end seals were poorly executed in manufacturing, as they were covered in metal chips from the tapped holes in the extrusion, which left water able to ingress. Luckily, I was able to fix it and at the same time make some other improvements. Thermally, the lights performed really poorly. They have a massive heatsink as their enclosure, so should have been doing pretty well, but areas of the boards were still exceeding 100 degrees Celsius. The heatsink was also just painted rather than anodized. It would not have cost them very much extra to anodize the enclosure to make them far more corrosion resistant. The board layout seems to be the cause of the very poor power performance. It's a horrific design for a switch mode power supply, but underdriving the LEDs this much will make them last longer, so I guess it has that going for it. There's not much I can do about the poor layout decisions or bad choice of capacitor, but I can improve the waterproofing and thermal performance. I conformal coated the boards, which makes it so water cannot get to any of the conductive metal on the boards to cause corrosion. The boards should work fine underwater after having conformal coat applied. I didn't coat the top of the LEDs, just the sides, as the conformal could act like a lens and do weird things to the LED light pattern. The board is an aluminium PCB, so covering everything with conformal coating isn't going to provide much thermal penalty. Improving the thermal performance of the light bars was very easy. The factory barely put any thermal compound on the board at all, so it didn't make contact with the giant heatsink. Air is a terrible thermal conductor, which explains why the board was over 100 degrees Celsius in a massive heatsink enclosure that was under 50 degrees. At this point, I could have used toothpaste or peanut butter as thermal compound and greatly improved the thermal conductivity of the board to the enclosure. Instead, I used a tub of very cheap metallized thermal paste and applied a thin but complete layer of paste across both the enclosure and circuit board to ensure excellent contact. Checking the board again with a thermal camera shows a great improvement in overall temperature, with just the poor component choices being hotspots. There's not a lot I can do about this, as the layout is terrible anyway, so I left them as they are. If the boards die, I can put better parts on at that point in time. It's very satisfying to see a large improvements from a small amount of effort. When reassembling the light bars, I made sure to clean the ends of the aluminium extrusion and the rubber seals to make sure they have good contact without debris in the way. The debris creates passages for water to infiltrate the enclosure. The front cover is sealed with something that's a bit like endless O-ring, but more gummy and squishy. It looks like the intent was to tuck this between the end seals and the enclosure. Then the screws push down on the clear plastic to make the seal. I managed to pull these to where they should be to ensure the design would work as well as it could. I then crimped pins for standard waterproof automotive connectors onto the wires to make wiring them up in the truck easier. With the light bars fixed, I could install the mounting brackets and start drilling some holes in the truck. I laser cut a drilling template to hold the lights at a 10-degree angle, which I figured would give me the best light coverage behind the truck. It's really awkward drilling from the inside of the truck, but it allowed me to align the mounts to the roller door easier than from the outside. I left all the wiring of the truck to the end, as I needed a clear, dry couple of days. There was going to be a lot of crawling around in the ground, so I wanted to make sure the ground was dry and snow-free before working on the wiring. I wanted to improve the lighting inside the box of the truck as well, knowing that I'd probably be loading things into the truck at the end of the day when packing to move. We also knew that we would be using the truck as a dry, clean outside area for working on projects. It would also be acting as temporary workshop space and potentially as a spray booth when we get to making windows. Having good lighting, no matter the weather or time of day, is going to be important. Watch closely because this next bit is riveting. I'm going to attach the LED strips to aluminium 45-degree extrusions to get the most out of the light. The diffusers on the extrusion will not only protect the LEDs, but provide slightly softer light. There's already a good aluminium lip at the top of the box, so I drilled it and used rivets to attach the strips to each side and front of the box. I was going to attach the extrusion by drilling and tapping holes, then use screws, but that is not only a lot of work, but screws are not ideal for high vibrations of a truck. I want to have nice, even lighting, and lighting that would also allow filming in. I really struggled to find some high color rendering index LEDs that would be 24 volt friendly and also not cost a small fortune. I went with 12 volt LEDs instead and wired them in series to make them 24 volt friendly. High color rendering index LEDs are really important, both for cameras and for humans. Cheap LEDs make red colors look very muted if they show up much at all. The human eye is evolved to deal with the spectrum of light from our closest star. Low-cost LEDs can generate a large amount of light, but the spectrum of light can be very poor. A typical low-cost LED can be missing 40 to 50% of the light spectrum you get from the sun, particularly towards the red end of the spectrum. White LEDs are just a blue emitter with a blend of phosphors on it, which shifts the emitted light's wavelength. It's more expensive to create a blend of phosphor which radiates something that closely resembles sunlight. Low CRI LEDs make things look muddy, and food looks pretty gross, as the light is heavily stacked towards the blue and green, with perhaps just a small spike of light in the red wavelength to make it look more white, rather than the full range of red we perceive. Quality LEDs are not only important for your home, but also if you're doing any creative work, be it woodwork, electronics, cooking, or arts. I pre-wired all my LED strips after measuring them and the cable lengths in the truck. The first LED strip from the switch only gets the positive wire connected. Its negative connection then goes to the positive wire of the next strip. Effectively, this puts 6 LEDs in series rather than just the 3 on the LED strip, giving me a 24 volt compatible strip. You might have noticed if you've used LED strips in the past, you can cut them every 3 or 6 LEDs. This is because each of these groups is wired in series. The negative or cathode of one LED connects to the positive or anode of the next LED in the series, which gives you about a 3.2 volt drop per LED, and the little black components are resistors which limit the current to something that won't cause the LEDs to burn out instantly if the voltage is higher than the forward drop of the diodes. I printed a little box for the switches I bought off Amazon. They're pretty fun switches with little silk screened icon and text. The icon lights up when the switch is on, and there's a bar at the bottom which lights up when it has power to make it easy to see at night. In the box, I wired these up so the little light is always on. It doesn't draw enough power to drain the truck battery very much, and it makes it easy to find the switches at night. I made the box with a protective lip like the tail lift control has to prevent accidentally damaging or activating the switches. I also really overbuilt it and printed it in PETG, which is very tough. I'm using brass inserts for the threaded holes. Directly threading plastic is fine, but it doesn't last as long if you need to remove the screws more than a couple of times. The brass should also cope with the vibrations better. The print quality on the top surface was really rubbish, as I didn't realize my extruded tension was set for running flexible filament, so it kept losing steps on the much harder PETG. Oops. The slowly printed sidewalls came up fine though, so I didn't bother reprinting. I wanted the reverse spotlights to be able to get activated from either the cab of the truck or from the box to use as rear work lights. You don't really see three-way switches like you might use in a household lighting circuit in this form factor. So I'm using a relay in my switch box to control the lights from the cab of the truck. If either switch is on, the rear lights will be on. This suits me fine as it's pretty obvious when they are on even in daylight, so you probably wouldn't drive off with the rear switch turned on. The switch in the cab has a much smaller body than the original switches and switch blanks, so I 3D printed an adapter to hold the new switch. Unfortunately, these switches work in the opposite direction of the truck's cab switches, with down being off and up being on with the new switch. While I had the cab trim completely removed, I also fitted a 24 volt to 12 volt power supply to run the cigarette lighter off. The lighter socket was 24 volt, and I wanted to run a little USB power delivery car charger in there to run things like phone, sat nav, or camera. The truck has a 12 volt socket in the cab, but it's a Hella style plug rather than a standard lighter socket. I bought a couple of fully sealed switch mode power supplies off Amazon and ran them at 28 to 30 volts and their advertised currents with my DC load until I had a winner. The others either got way too hot, couldn't meet their advertised ratings, or died from being run at their claimed specs. I also fitted the reverse camera monitor to the cab and ran the cables under the trim. I'm running everything I've added to the cab off the lighter socket cables as it has a 20 amp fuse and the wiring was the easiest to access and hack to my needs. To mount the monitor, I'm ashamed to admit I just used wood screws directly into the plastic of the dashboard, but it does hold the screen nicely. The cheap reversing camera kit I bought came with 2 cameras, so I wired one up at the top of the box looking back and down. The other is mounted much lower on the rear chassis structure, pointing straight back. The connectors are kind of big and I didn't want to use quite that much sealant to fill a hole as large as the connector required to make it waterproof. So I laser cut a silicone gasket out to fit the cable and mount the camera. For me, the biggest challenge of this whole project was running the cables from the cab back to the box. It's a fairly straightforward cable run. The cables come out of the cab very easily, but it's just so awkward getting the cables through and around everything under the truck. With the cab tilted, I was able to get the cables I had already run down from the cab into the engine area and under the box. Under the truck, I ran some new cables from the battery to run all the lights off. It's quite convenient to be able to sit under the truck, but it's also quite a stretch to reach around some stuff like the exhaust components and brake controls. Once the cables made it all the way back, I had to figure out how to get them into the box. The tail lift controls seemed to go up behind the roller door guide rails, and I could see the plywood box trim from under the truck. I tried unscrewing the trim and lifting it, but it appears to be glued to the truck wall pretty securely, as I couldn't get it to move at all. I ended up drilling through the bare metal trim of the deck to make a hole big enough for the reverse camera connector. Only, my largest drill bit was a bit too small, so I filed the hole to size and ran the cable up into some conduit to keep it tidy and safe. This all goes to the switch box with a single connector for the battery and cab switch for the rear lights. The other connectors are for the rear lights themselves and for the box lighting.